If you think you understand the Earth's weather, you are probably wrong. We must now dive into a realm that remains largely hidden from view but is equally crucial: our oceans. Covering more than 70% of the Earth's surface, the oceans play a pivotal role in regulating our climate, acting as both a heat sink and a source of immense energy. The story of Earth's climate would be incomplete without understanding the vast, dynamic systems of currents that traverse our oceans. These currents, driven by both wind and the rotation of the Earth, create a complex web of interconnections that distribute heat around the globe. The most well-known of these is the Gulf Stream, a powerful Atlantic Ocean current that transports warm water from the Gulf of Mexico across the Atlantic to Western Europe. This current is a major reason why places like the United Kingdom experience milder winters compared to other regions at similar latitudes. But the Gulf Stream is just one player in a much larger system known as the global conveyor belt, or thermohaline circulation. This global-scale circulation system moves water around the world's oceans through a combination of surface currents and deep water flows. Driven by differences in water temperature and salinity, this slow-moving conveyor belt takes about 1,000 years to complete one full cycle. It's a journey that influences climate patterns on a global scale, from the monsoons in Asia to the droughts in Africa. Yet the health of this conveyor belt is not guaranteed. Recent studies suggest that it is slowing down, possibly due to the melting of polar ice caps and the subsequent influx of fresh water into the oceans. This disruption could have far-reaching consequences, potentially altering weather patterns and exacerbating the extremes of climate change. Another crucial aspect is the El Niño Southern Oscillation, ENSO, a periodic fluctuation in sea surface temperatures and atmospheric pressure over the equatorial Pacific Ocean. El Niño events, characterized by warmer ocean temperatures, can lead to severe weather conditions, including heavy rains and flooding in some regions and droughts in others. Conversely, La Niña events, marked by cooler ocean temperatures, often bring about opposite effects. These oscillations are natural phenomena, but their intensity and frequency can be influenced by broader climatic changes. The oceans also play a vital role in absorbing carbon dioxide from the atmosphere. Phytoplankton, tiny marine plants, take in CO2 during photosynthesis, contributing to what is known as the biological carbon pump. However, as ocean temperatures rise and water chemistry changes, the efficiency of this natural carbon sink could be compromised, leading to higher concentrations of greenhouse gases in the atmosphere. Understanding the intricate and often hidden workings of our oceans is essential for grasping the full picture of Earth's climate system. It's a reminder that what happens below the surface can have profound impacts above it. As we continue our exploration, we'll delve deeper into the interconnected elements that shape our climate, from the winds that blow to the ground beneath our feet. Stay with us as we uncover more of Earth's complex climate puzzle and seek to understand how our actions today will shape the world of tomorrow. Let's turn our gaze skyward to the celestial dance that shapes our seasons, the Milankovitch cycles. These cycles are subtle shifts in Earth's movements that have profound impacts on our climate. Imagine Earth's orbit as a nearly perfect circle, giving us a relatively consistent amount of sunlight all year round. However, once our orbit becomes elliptical, there are parts of the year where we're further from the sun and thus colder, and parts where we're closer and warmer. As it happens, the perihelion of the Earth's orbit, or the bit where we're closest to the sun, happens roughly on January 3rd, while the aphelion, or the bit where we're furthest away, happens on roughly July 4th. I'm recording this in the UK, which means for my hemisphere, January is winter. So for me, this is quite nice. Although we are in the phase right now of this cycle where the Earth's orbit is more circular than it is elliptical, we still experience a 7% difference in the amount of sunlight we receive in January compared to July. This sunlight difference means that my northern hemisphere's winters are warmer, while our summers are milder. In the southern hemisphere, the reverse is true. Because they are experiencing summer during this warmer phase, their summers become even warmer. Winters become colder. And that's just at this stage of the 100,000-year Milankovitch cycle. As the Earth's orbit becomes more elliptical, that 7% sunlight difference turns into a 23% difference, quite significant. You might think this seems overall a little unfair on the southern hemisphere. The northern hemisphere benefits from this cycle stabilizing its seasons, while this cycle makes the southern hemisphere's seasons more extreme. Don't worry though, as another cycle is at play to bring things full circle. This current seasonal rotation happens because the Earth's tilt is consistent as it orbits. Except, it isn't consistent. Little by little, the angle the Earth's axis is rotating along is changing too. It moves as if it were drawing a circle on the sky above it, in a cycle that lasts 26,000 years. One upshot of this is that while our axis is currently pointing at the North Star, or Polaris, this will eventually no longer be the case. Over time, it will point at different stars, before eventually circling back to point at Polaris again. The other upshot of this is that in 13,000 years, the Northern Hemisphere will be having its summer in January, while the Southern Hemisphere will be the one with a white Christmas. So then it will be us experiencing a more profound seasonal variation. While harsher winters are unpleasant, at least they go away after a few months. This is nothing. There are Milankovitch cycles that create winters that last for thousands of years. Or, to speak more accurately, there are Milankovitch cycles that help cause ice ages. We don't fully understand how ice ages come and go. There are numerous theories. However, it must be noted that some of the 100,000-year spans of ice ages line up extremely well with the 100,000-year Milankovitch cycles. For instance, there is a cycle whereby the plane on which the Earth rotates around the Sun rises and falls over the course of 100,000 years. This change in its orbital inclination does not obviously explain why it is that the Earth would be getting colder or warmer. After all, the Earth is still the same distance from the Sun. However, it lines up so perfectly with the time periods ice ages were occurring at over the last 800,000 years that scientists conclude there must be a connection. Perhaps cosmic dust lying in the plane of Earth's orbit blocks out some sunlight when we are at one inclination, but is not in the way when we are at another. This could go some way towards explaining the occurrence of ice ages during these time periods. Whatever the case, there is at least one other cycle that influences the arrival of ice ages on Earth, and this might perhaps be the most important for us today. It is the tilt of the Earth's rotation. I already mentioned that this axis of tilt rotates around the planet, but it also changes the angle at which it does this. Over the course of 41,000 years, it alternates between 22.1 degrees and 24.5 degrees. At the moment, it is 23.4 degrees and is declining. You might think that this is a good thing. The smaller the angle of tilt, the less extreme our seasonal temperature variations might be, and the warmer our winters will become. Surely that is a good thing for avoiding ice ages. Surprisingly, it is quite the opposite. Left to its own devices, this lessening tilt would lead us into another spreading of the ice sheets and cooling of the planet that would hit its peak in 9,800 years. It is not the harshness of the winter that causes this spread, but strangely enough, it is the mildness of the summers. You see, when winters occur, snow builds up at the top of mountains and in cold polar regions. In warm summers, this snow tends to melt away. However, if the summer is mild enough, the snow sticks around, becoming a more permanent feature of the landscape. Icy snow is white in color, reflecting sunlight and further cooling the planet. This is how the dance of celestial mechanics and Earth's tilt can lead to the grand winters we know as ice ages. By understanding these cycles, we gain a clearer picture of the natural rhythms of our planet and how they intertwine with the immediate influences of our oceans. In the dance of Earth's natural rhythms, there is one cycle that stands out for its unpredictability and profound impact on our daily lives: the El Niño Southern Oscillation, or ENSO. Unlike the long-term, slow-moving Milankovitch cycles, ENSO operates on a much shorter timescale, with intervals ranging from 2 to 7 years. It is a cycle of warming and cooling sea surface temperatures in the central and eastern tropical Pacific Ocean, which in turn disrupts weather patterns across the globe. But what exactly are El Niño and La Niña, and how do they shape the world we live in? El Niño, named after the Christ child by 17th century fishermen who noticed a warming of the waters around Christmas, is the warm phase of ENSO. During an El Niño event, the trade winds that normally blow from east to west along the equator weaken or even reverse. This allows warm water from the western Pacific to flow eastward, spreading across the central and eastern Pacific. As a result, regions like the western coast of South America experience significantly warmer sea temperatures. This warming disrupts normal weather patterns, leading to increased rainfall and flooding in some areas while causing droughts in others. For example, El Niño can bring heavy rains to the southwestern United States and Peru. while Australia and Indonesia may suffer from severe droughts. On the flip side, La Niña, which means the little girl in Spanish, is the cool phase of ENSO. During a La Niña event, the trade winds strengthen, pushing warm water further west and allowing cooler water to upwell in the eastern Pacific. This results in a cooling of sea surface temperatures in the central and eastern Pacific. La Niña typically brings opposite weather impacts compared to El Niño. It can lead to drier conditions in the southwestern United States and Peru, while Australia and Indonesia might experience increased rainfall and flooding. The impacts of ENSO are far-reaching, affecting not just weather patterns but also ecosystems, agriculture, and even economies. For instance, the 1997 to 1998 El Niño event caused widespread coral bleaching, devastating marine ecosystems. It also led to crop failures and food shortages in various parts of the world, highlighting the interconnectedness of our global climate system. Despite its unpredictable nature, scientists have made significant strides in understanding and forecasting ENSO events. By monitoring sea surface temperatures, wind patterns, and other climate indicators, they can provide early warnings, allowing communities to prepare for the potential impacts. As we continue to study ENSO, we gain valuable insights into the intricate workings of our planet's climate system. It serves as a reminder of the delicate balance that sustains life on Earth and the importance of being attuned to the natural cycles that govern our world. Modern technology and scientific advancements are helping us predict and mitigate the impacts of these powerful climate cycles. While the natural cycles of our planet have been influencing climate and weather patterns for eons, there is a new player in the game: human activity. From the burning of fossil fuels to deforestation, our actions are altering the delicate balance of Earth's climate system in unprecedented ways. Greenhouse gases, like carbon dioxide and methane, are being released into the atmosphere at an alarming rate. These gases trap heat, leading to a phenomenon known as global warming. Unlike the cyclical natural events, this warming is steady and relentless, pushing global temperatures higher year after year. This not only exacerbates the impacts of natural cycles like ENSO, but also introduces new challenges for ecosystems and human societies alike. For instance, the increased frequency and intensity of extreme weather events, such as hurricanes, heat waves, and heavy rainfall, can be linked to our warming planet. Coastal cities face the threat of rising sea levels, while inland areas may suffer from prolonged droughts. The ripple effects touch every corner of the globe, affecting agriculture, water supplies, and even human health. Yet there is hope. Advances in renewable energy, sustainable agriculture, and conservation efforts offer pathways to mitigate our impact. By understanding and respecting the natural cycles that govern our world, we can learn to live in harmony with them rather than in opposition. In the end, the story of Earth's climate is not just one of natural forces, but also of human choices. The future of our planet will be shaped by how we respond to the challenges before us. As we continue to explore and understand the complex interplay of natural and human factors, we hold the power to steer our world toward a more sustainable and resilient future. Move forward. The question remains, how will we adapt to the changing climate? It's a challenge that requires global cooperation, innovative thinking, and a commitment to sustainable practices. But amidst the uncertainty, there are glimmers of hope and ingenuity that light our way. Consider the advancements in green technology. Solar panels, wind turbines, and electric vehicles are becoming more efficient and affordable, reducing our dependence on fossil fuels. Countries around the world are investing in renewable energy sources, aiming to cut their carbon emissions and transition to a cleaner future. In agriculture, farmers are adopting sustainable practices to cope with the changing climate. Techniques like crop rotation, agroforestry, and precision farming help maintain soil health and increase resilience against extreme weather. Urban areas are also transforming, with green roofs, vertical gardens, and smart city planning reducing the urban heat island effect and improving air quality. Communities are coming together to build resilience. Coastal cities are enhancing their defenses with seawalls, mangrove restoration, and flood management systems. Inland, efforts to conserve water and restore natural habitats are helping to mitigate droughts and protect biodiversity. Education and awareness play a crucial role. By understanding the science behind climate change and its impacts, individuals can make more informed choices. Simple actions like reducing waste, conserving energy, and supporting sustainable businesses collectively make a significant difference. Yet, the path ahead is not easy. Political will, economic challenges, and social inequalities complicate the journey. But history has shown that humanity is capable of remarkable progress when united by a common goal. The climate crisis is a call to action, an opportunity to redefine our relationship with the planet and each other. As we face this defining moment, we must remember that the future is not set in stone. It is shaped by our decisions, our innovations, and our willingness to act. Together, we can build a world that not only survives but thrives in harmony with nature. As we navigate the complexities of climate change, it's easy to feel overwhelmed by the scale of the challenge. However, amidst the global efforts and grand strategies, there lies a powerful truth: individual actions matter. Each of us holds the potential to make a meaningful impact. Consider the simple act of reducing waste. By recycling, composting, and choosing products with minimal packaging, we can significantly cut down on the amount of waste that ends up in landfills and oceans. Imagine the collective impact if millions of people adopted these habits. Energy conservation is another area where individuals can contribute. Turning off lights when not in use, using energy-efficient appliances, and insulating homes can reduce our carbon footprint. Small changes in our daily routines, like using public transportation, biking, or walking instead of driving, can also add up to substantial reductions in greenhouse gas emissions. Supporting sustainable businesses and products is a powerful way to drive change. By choosing to buy from companies that prioritize eco-friendly practices, we can encourage more businesses to follow suit. Our purchasing decisions send a message about the kind of world we want to live in. Community involvement amplifies individual efforts. Participating in local environmental groups, volunteering for cleanup events, or advocating for green policies can create a ripple effect of positive change. When communities come together with a shared purpose, they can achieve remarkable outcomes. Education and awareness are crucial. By staying informed about climate issues and sharing knowledge with others, we can inspire more people to take action. Social media, blogs, and community events are powerful platforms for spreading awareness and mobilizing collective efforts. The journey towards a sustainable future is not just about grand gestures and large-scale initiatives. It's about the everyday choices we make and the cumulative effect of those choices. Every action, no matter how small, contributes to the larger goal of protecting our planet. As we face the challenges ahead, let us remember that we are not powerless. Each of us has a role to play in this global effort. By taking responsibility for our actions and encouraging others to do the same, we can create a wave of positive change that transcends borders and generations. As we've seen, individual actions can have a significant impact on our environment. But what happens when these individual efforts converge into a collective force? The power of collective action can create a ripple effect that transcends communities and even nations. Consider the global movements that have sparked change. From grassroots campaigns to international environmental agreements, collective action has repeatedly shown its strength. Take the example of the Paris Agreement, where nations came together to commit to reducing greenhouse gas emissions. This landmark accord wouldn't have been possible without the pressure and advocacy from millions of individuals worldwide who demanded action. On a smaller scale, local communities are making waves too. In cities around the world, community gardens are transforming urban spaces into green oases, reducing carbon footprints and fostering local biodiversity. These initiatives often start with just a handful of dedicated individuals, but quickly grow as more people see the tangible benefits. Schools and universities are also playing a crucial role. Student-led environmental clubs and sustainability programs are educating the next generation about the importance of protecting our planet. These young advocates are not only learning but also leading, inspiring their peers and families to adopt more sustainable practices. Businesses too are feeling the ripple effect. Consumer demand for sustainable products is pushing companies to innovate and adopt greener practices. By choosing to support businesses that prioritize sustainability, individuals are driving a market shift towards a more eco-friendly economy. Even in the digital realm, collective action has found a powerful platform. Social media campaigns and online petitions can quickly gather millions of supporters, influencing policy decisions and corporate behaviors. The internet has made it easier than ever to mobilize and amplify our voices, creating a global community united by a common cause. The beauty of collective action is that it harnesses the strength of diverse efforts, creating a synergy that magnifies each individual contribution. When we come together with a shared purpose, we can tackle even the most daunting challenges. So, As we continue our journey towards a sustainable future, let's remember that we are stronger together. Each small action we take can inspire others, and together, we can create a wave of change that reaches every corner of the globe. The ripple effect of our collective efforts can build a world where both people and the planet thrive. The time for action is now, and the power to shape the future is in our hands. Together, we can make a difference. Ripple effect of collective action. Let's take a moment to appreciate the unseen guardians that make life on Earth possible. These natural forces operate silently, often unnoticed, yet their influence is profound. One such guardian is the Earth's magnetic field, a shield that deflects deadly solar radiation and ensures our planet remains habitable. But what happens when this shield weakens or even reverses? Geomagnetic reversals, though rare, have occurred throughout Earth's history. During these periods, the magnetic field can drop to as low as 10% of its current strength, leaving us vulnerable to increased radiation from space. This could lead to devastating consequences, from climate shifts and mass extinctions to the disruption of electrical grids and satellite communications. The process behind these reversals is rooted deep within the Earth, in the molten iron core that generates our magnetic field. Picture a giant hourglass, slowly running out its sand until a dramatic reversal occurs. Scientists believe we may already be in the early stages of such a reversal, with fluctuations in the Earth's magnetic field indicating that change is on the horizon. So, should we be worried? The answer is complex. While the build-up to a geomagnetic reversal poses significant challenges, understanding these processes can help us prepare and adapt. Advances in technology and science can mitigate some of the risks, ensuring that we continue to thrive despite the shifts in our planet's magnetic heart. As we navigate the uncertainties of our changing world, let's remember the importance of these unseen guardians. They remind us of the intricate balance that sustains life on Earth and the need for continued vigilance and innovation. Our journey towards a sustainable future is not just about immediate actions, but also about understanding and respecting the powerful yet invisible forces that shape our existence. The Earth's magnetic field, the polar vortex, and the jet streams, all these elements work in harmony to protect and sustain us. By studying and respecting these natural rhythms, we can better prepare for the challenges ahead. Unseen guardians of our planet, we find ourselves at the very heart of Earth, its core. The Earth's magnetic field, which deflects deadly solar radiation and allows life to flourish, is generated by the complex dance of molten iron in our planet's core. This magnetic shield protects us by preventing harmful radiation from breaking down our DNA, causing mutations and cancers. Scientists are still unraveling the mysteries of why some planets have magnetic fields while others do not. The leading theory suggests that the Earth's core acts as a giant dynamo. It's a principle of physics. Electrical fields can create magnetic ones and vice versa. In a power plant, moving a magnet through a coil of wires generates electrical current. Similarly, the motion of electrons creates a magnetic field, as described by Faraday's law of induction. For Earth, this dynamo effect is a delicate, intricate process. Our core must be partially liquid, which it is. Above the solid inner core lies a liquid outer core, where temperatures reach up to 6,000 degrees Celsius, comparable to the surface of the sun. This extreme heat, combined with lower pressure, keeps the iron and nickel in a flowing state. As the temperature drops away from the center, it creates circulation. Hot material rises, cools, and then falls again, generating electrical currents. But why does Earth have just one north and one south magnetic pole? The Coriolis effect, caused by Earth's rotation, is believed to unify these magnetic fields, causing the flows of iron to spiral rather than move in straight lines. This creates a coherent magnetic dipole with a unified field pointing in the same direction. However, this process is inherently unstable. Our magnetic field constantly fluctuates and wobbles. The North Magnetic Pole, for example, has shifted about 1,100 kilometers since 1831, moving from Canada towards Siberia, and its rate of motion has increased from 16 kilometers per year to roughly 55 kilometers per year. While these wobbles are usually minor, complete geomagnetic reversals have occurred 183 times in the last 83 million years. Scientists discovered this by studying iron in ancient magma layers, which aligned with Earth's magnetic field as they cooled. These layers show periods where the magnetic field was reversed. On average, these flips happen every 450,000 years, although there have been gaps as long as 40 million years. The last reversal was 750,000 years ago, leading some to speculate that we are overdue for another. However, the timing of these flips is unpredictable. Understanding the core of our existence and the magnetic shield it generates is crucial for preparing for future challenges. As we continue to study and respect these natural processes, we can better safeguard our planet and ensure a thriving future for generations to come. As we ponder the intricate dance of Earth's core and its magnetic field, a crucial question arises. How resilient is our planet in the face of these cosmic challenges? Earth's history tells a story of survival and adaptation. Despite shifts in the magnetic field, life has found ways to endure and thrive. One remarkable example is the extremophiles, organisms that flourish in the most inhospitable environments, from the scalding hydrothermal vents at the ocean floor to the toxic sulfur springs. These resilient creatures remind us of life's tenacity and adaptability. Moreover, humanity itself has shown an incredible capacity for innovation and resilience. The development of space technology, medical advancements, and sustainable energy solutions are just a few examples of how we can adapt to changing conditions. The potential for future technologies to shield us from increased solar radiation or to protect our electrical grids from solar storms is vast. Yet, resilience isn't just about technology. It's about community, cooperation, and the human spirit. In the face of adversity, people come together, share knowledge, and support one another. This collective strength is a testament to our ability to overcome even the most daunting challenges. As we look to the future, we must continue to study and understand the complex dynamics of our planet. With this knowledge, we can better prepare for the uncertainties ahead. But more importantly, we must foster a spirit of resilience and cooperation, ensuring that we not only survive but thrive in harmony with our resilient planet. In the end, the story of Earth's magnetic field is a reminder of the delicate balance that sustains life. It's a call to cherish and protect our home, to innovate and adapt, and to work together to build a resilient future for all. Earth's resilience and adaptability, we must also prepare for the challenges that lie beyond our planet. The next frontier in our journey is understanding and mitigating space weather. Those cosmic events stemming from our sun that can have profound impacts on our technology and way of life. Imagine a world where satellites are knocked offline, power grids are disrupted, and astronauts face unprecedented dangers. This isn't a scene from a sci-fi movie. It's a potential reality driven by the sun's dynamic activity. The South Atlantic anomaly, a weakening of Earth's magnetic field in a specific region, is a stark reminder of the vulnerabilities we face. This zone might not influence life on the ground directly, but it's dangerous enough to have fried satellites and threatened astronauts. The Hubble Space Telescope even has to power down every time it passes through it. Now envision this anomaly on a global scale, a scenario that could unfold during a geomagnetic reversal. The South Atlantic anomaly has been expanding, hinting at the possibility of another geomagnetic wobble or even a full-blown reversal. While such an event may not end civilization as we know it, it would undoubtedly bring significant changes. Species could perish, and humans would have to adapt to a more hazardous space environment. As we approach the peak of the current solar cycle in 2025, we can expect more frequent solar flares, coronal mass ejections, and other space weather phenomena. These events could lead to health issues, technological disruptions, and climate variations. The sun's 11-year cycle acts as a metronome, influencing the rhythm of life on Earth. But we aren't helpless in the face of these cosmic challenges. Advances in space weather forecasting, the development of more resilient technologies, and international cooperation are crucial steps in preparing for the future. By understanding the sun's cycles and their impacts, we can better protect our satellites, power grids, and astronauts. Moreover, this knowledge empowers us to take proactive measures to safeguard our planet and its inhabitants. From early warning systems to innovative engineering solutions, humanity's ingenuity and resilience will be our greatest assets in navigating this next frontier. As we continue to explore the unseen forces that shape our world, let's also look to the cosmos with a sense of wonder and responsibility. The story of space weather is not just a scientific curiosity, it's a call to action. As space weather becomes a growing concern, it's crucial to understand how deeply interconnected we are with the cosmos. The very technology that we rely on daily, our smartphones, GPS, and even the internet, is vulnerable to the whims of the sun. But beyond the technical implications, There's a profound human element to this story. Imagine a world where the flicker of the auroras, those mesmerizing northern and southern lights, becomes a common sight far beyond the polar regions. While beautiful, these lights are a reminder of the sun's powerful influence on our planet. They serve as nature's own warning system, signaling heightened solar activity and potential disruptions. Consider the astronauts aboard the International Space Station. For them, space weather isn't just a scientific curiosity, it's a matter of survival. During solar storms, they seek refuge in specially shielded areas to avoid harmful radiation. Their experiences underscore the importance of understanding and predicting these cosmic events. Back on Earth, communities in the far north, like those in Canada and Scandinavia, have learned to live with the sun's cycles. Power companies in these regions have developed advanced strategies to protect their grids from geomagnetic storms, ensuring that homes stay warm and lights stay on even during the most intense solar activity. But it's not just about survival, it's about thriving. Scientists and engineers are working tirelessly to develop new technologies that can withstand the sun's outbursts. From more resilient satellites to improved forecasting systems, human ingenuity is rising to meet the challenge. Even as we look to the stars with a mix of awe and caution, there's a sense of unity in our efforts. International collaborations, like the ones between NASA, ESA, and other space agencies, highlight the global nature of this endeavor. Together, we're building a future where we're not just reacting to space weather, but anticipating and mitigating its effects. So, the next time you see the auroras dancing in the sky or experience a brief GPS glitch, remember, we are all connected by the sun's rhythm. And just as we've adapted to countless challenges on Earth, we will continue to adapt to the cosmic forces that shape our world. As we navigate this new frontier, let's do so with a sense of wonder, resilience, and unity. The story of space weather is not just about science, it's about the human spirit and our capacity to rise to any challenge. The sun isn't the only astronomical body that influences us. Much like the sun, the moon is an inescapable part of life on Earth. The moon has an immense impact on our planet. The most obvious influence of the moon is its role in creating the tides. The gravitational pull between the Earth and the moon causes the oceans to bulge, leading to high and low tides. This rhythmic ebb and flow has shaped the lives of countless marine species, from the smallest plankton to the largest whales. Coastal ecosystems, too, are finely tuned to the moon's cycles, with many species timing their reproductive cycles to the lunar calendar. But the moon's influence extends beyond the oceans. Research has shown that the lunar cycle can affect human behavior and biological rhythms. For centuries, farmers have planted and harvested crops according to the phases of the moon, following practices passed down through generations. Some studies suggest that the full moon can even impact human sleep patterns, with people experiencing less deep sleep and more wakefulness during a full moon. The moon also plays a crucial role in stabilizing Earth's axial tilt. Without it, our planet's tilt would vary wildly, leading to extreme changes in climate and potentially making Earth a much less hospitable place for life. The moon's presence has provided a consistent environment that has allowed life to flourish. As we look to explore and perhaps even colonize the moon, understanding its influence on our planet becomes even more vital. The moon's resources, such as water ice in its shadowed craters, could support future lunar bases and serve as stepping stones for deeper space exploration. The lessons we learn from the moon could help us build sustainable habitats on other planets, ensuring humanity's future among the stars. In the grand tapestry of the cosmos, the moon is our closest celestial neighbor, guiding us with its gentle light and steady presence. Its influence is a reminder of the interconnectedness of all things, from the tides of our oceans to the rhythms of our lives. You likely have already heard how its cycles influence our wildlife, affect our climate, and create tides. We tend to imagine that the moon and the Earth's gravities cause them to circle each other in a relatively stable, synchronized harmony. But as is so often the case, nature is not as simple as we imagine it. Instead, every 18.6 years, the moon's orbit undergoes a subtle revolution, a shift in its alignment between us and our sun that causes high tides to grow even higher, tipping us over the edge into dangerous flood territory. We've arrived at our sixth cycle. Its name is the lunar nodal cycle, or the precession of lunar nodes. This complex name refers to a specific feature of the moon's orbit of the Earth. You likely know that every 29.5 days, the moon orbits the Earth. However, this orbit is not flat, or to be more specific, there is a 5-degree difference between the angle of the Moon's orbit and the ecliptic plane, the 2D plane on which the Earth orbits around the Sun. For half of the month, the Moon is slightly higher than the plane of the ecliptic. For the other half, it drops below it. Naturally, this means that there are 2 crossover points, or 2 nodes, an ascending node and a descending node, that mark the point whereby the Moon goes from one side over to the other. And it is these nodes that move over the course of the 18.6-year cycle, slowly rotating around the planet in one complete revolution. The nodes themselves are what causes the problem. To understand why, let's recap what we know about tides. You may already be familiar with how the Moon's gravity pulls the Earth's water towards it, causing a bulge in sea levels on the side closest to it that we call high tide. You likely also know that this happens on the side of the planet furthest away from the Moon. Rather than being caused by gravity, this second bulge is caused by centrifugal forces, as the Earth and the Moon's gravitational pull on each other causes them to behave like 2 dancers, holding each other by the arms and spinning across the dance floor. While it's mostly the Moon moving, due to the Earth being much more massive, the Earth is also swung around a little. The water behind it is thus trying to fling off into space through its raucous spinning, causing the second high tide. The Sun also has a role to play in tide formation, albeit to a lesser degree. It's a bigger mass which would cause a greater pull if it were closer, but its further distance means that the Sun's effect is only 1/3 as big as the Moon. When the Moon and Sun are aligned, we get extra large tides called spring tides. This happens 6 to 8 times a year. When not aligned, they partially cancel each other out, causing smaller tidal extremes known as neap tides. So now consider the influence of lunar nodes on this tidal tug-of-war. During spring tides, the pull of the Sun and the Moon working in unison causes the highest tides and the largest risk of floods. However, the Sun and Moon are never more aligned than they are at a node. During the rest of each 9.3-year phase, they are not quite tugging in the same direction, so tides are more temperate. At a node, that's where things get more serious, and risk of floods become highest. The last time this alignment occurred in September 2015, the UK and the US both issued major flood warnings to their citizens. In September itself, there were floods, albeit minor ones, but it was only when heavy rain combined with the strength of the lunar nodes a couple of months later that the real damage was inflicted. In the US in October, South Carolina saw flash flooding that caused property damage and people having to be rescued by emergency services. At the end of December 2015, the UK was hit by some of the worst floods it had seen in a century. Combined with the power of Storm Desmond, flooding and storm damage caused an estimated £1.3 billion in damages. These floods can be highly damaging, but that in and of itself doesn't completely explain NASA's worry for the upcoming alignment in mid-2030. There is an extra element at play beyond the regular rhythm of this rising flood risk we have been seeing throughout the course of human history. Unfortunately, the next node's alignment with the Sun promises to be particularly devastating. The danger is that this phenomenon is combined with an already strained system, even more strained than it was in 2015. Over the last 100 years, we have seen steadily rising sea levels. When the next node aligns with the Sun in the mid-2030s, this will likely lead to a dramatic increase of floods on planet Earth. Worryingly, a new study led by the NASA Sea Level Change Science Team predicts that almost all U.S. mainland coastlines, Hawaii and Guam will have a huge leap in flood numbers when this happens. Some predictions claim this node, mysteries of our cosmic surroundings, it becomes clear that the Moon is just one cog in the grand celestial clockwork that governs our planet. But what about the other gears turning silently in the background? Welcome to the realm of celestial mechanics, where the gravitational forces of planets, stars, and even distant galaxies subtly influence the Earth's climate and environment. Take, for example, the Milankovitch cycles. These are long-term changes in the Earth's orbit and orientation towards the Sun, occurring over tens of thousands of years. These cycles affect the distribution of solar energy on Earth's surface, leading to periods of glaciation and warming. Essentially, these cycles have the power to usher in ice ages or warm interglacial periods, profoundly impacting the evolution of life on Earth. Then there's the role of Jupiter and Saturn, the gas giants whose immense gravitational forces can nudge asteroids and comets towards our planet, occasionally causing catastrophic impacts. These celestial bodies also influence the stability of the Earth's orbit and axial tilt, which in turn can affect our climate over millennia. The gravitational pull of other planets in our solar system can also cause slight variations in the Earth's orbit, known as orbital eccentricity. These variations can lead to changes in the Earth's climate, albeit on a much slower timescale compared to the rapid changes we're experiencing today due to human activity. Even the position of our solar system within the Milky Way galaxy can have an impact. As we orbit the galactic center, we pass through regions of varying stellar density and cosmic radiation, which can influence the Earth's atmosphere and climate over millions of years. Understanding these cosmic influences is crucial for gaining a comprehensive picture of Earth's climate system. It reminds us that while human activities are currently the dominant force driving climate change, we are also part of a much larger, interconnected cosmic dance. As we continue to explore these celestial mechanics, we gain not only knowledge but also a profound sense of our place in the universe. We are part of an intricate web of forces and influences that shape our world in ways we are only beginning to understand. So, as we look up at the night sky, let's remember that we are not just inhabitants of Earth, but participants in a grand cosmic ballet. And in this dance, every move we make reverberates through the fabric of the universe, reminding us of our responsibility to tread lightly and with awareness. Next, we'll explore how these celestial influences translate into tangible effects on our daily lives and what steps we can take to mitigate their impacts. The celestial mechanics and natural cycles that shape our world, we must turn our gaze back to Earth and reflect on our role in this grand symphony. The cycles in the position of the Earth, the ebb and flow of its winds, the churning of its core, and the far-reaching influence of its celestial neighbors all have an influence on the planet we live on. They move in rhythms that are predictable and solid, even if they sometimes take place over time spans that are so large that we don't always live to see them fully play out. However, it is crucial to recognize that human activity has become a significant player in this cosmic dance. Our actions, burning fossil fuels, deforesting vast areas, and polluting our oceans, are altering the natural balance of these cycles. While the Milankovitch cycles, the gravitational pull of Jupiter and Saturn, and the position of our solar system within the Milky Way operate on scales of thousands to millions of years, the changes we are causing are happening in mere decades. This rapid alteration is unprecedented and poses a challenge that our ancestors never faced. Yet as daunting as this may seem, we are not helpless. Knowledge is our greatest ally. By understanding the natural and human-driven forces at play, we can develop strategies to mitigate our impact and adapt to the changes already in motion. Take, for example, the Dutch, who built dams and utilized sand dunes to create ways to stay dry in their swampy land. This shows that there are ways in which we can observe nature and live alongside it. The bad news is, behind its ethereal beauty, our moon hides a power that, if just so combined, is set to overwhelm humanity's coastal settlements. However, there's always a little bit of good news too, as knowledge is a power of its own. By understanding our plight, we can look for solutions, both among already existing ideas and ways forward that have yet to be discovered. If we are to endure what is coming, it's high time for us to use our innate creativity and drive to adapt and survive, to work with our planet rather than against it. While it's not directly quite so influential in the cycles that govern the Earth, it seemed remiss of me to not mention an ethereal interplay between the sun and the moon that happens above us. These moments cause nature to become still and silent, as night unexpectedly becomes day, and hearts are moved in wonder. The sun darkens, leaving behind nothing but a shimmering, ghostly ring around a pitch-black orb that has to be seen to be truly understood for its significance. I am, of course, talking about solar eclipses. One just was seen in April 2024, and countless people went to watch it. A total solar eclipse is when an object moves in front of the sun, completely obscuring it, also known as an occultation of an object. This is the typical kind of eclipse we see on Earth, when at certain points in Earth's orbit, the orbit of the moon aligns with the sun. There is something special about an eclipse here on Earth, and I'm not just saying that out of some Earth-focused pride. By a bizarre but highly fortunate cosmic coincidence, the moon is the right size and distance from us that its angular diameter is almost identical in size and shape to the angular diameter of the sun in our sky. This leaves for an impressive spectacle, where the corona of the sun, or in other words, the sun's upper atmosphere, creates a ghostly aura around the moon. The corona, normally too dim to see, extends for hundreds of thousands of kilometers into space. Looking closely around the edge of a total solar eclipse, and you will also see the silhouette of the moon's craters along the outside, plus these reddish wisps coming off from the sun. These are prominences, millions of tons of charged particles, suspended in the sun's atmosphere by powerful magnetic fields. During an eclipse here on Earth, the moon casts a shadow about 250 kilometers in diameter, which moves across the Earth as the moon orbits. In the case of the eclipse that happened last April, this shadow arrived at the Mexican west coastline, then made its way up through the United States until it passed into parts of Canada before moving over the ocean once more. The shadow moves across the Earth extremely fast, at roughly 1 kilometer a second. Witnessed from a high altitude, it is a majestic sight as the shadow shifts across the landscape. Satellites have also witnessed the movement of this shadow. The shadow isn't as sharp as you might expect, and this is due to the angular diameter of the sun and the moon, and their distance apart. The sun itself is huge, a whopping 1.4 million kilometers across. The moon is much smaller, at only 3,400 kilometers across. Now this image isn't to scale, but it shows visually why the shadow isn't sharp. The umbra is the shadow where the sun is completely obscured, and the penumbra is the shadow where the moon only partially obscures it. This part of the shadow is much wider than the 250 kilometers wide umbra shadow. So why doesn't the moon create eclipses every month when it orbits in front of the sun? Well, this is because the moon's orbit is not in line with Earth's orbit around the sun. This means there are only a couple of times per year when the alignment is right. This alignment of 3 celestial objects is known as a syzygy, a very cool word, but not something you'll need to remember for this video. Just thought you would find that interesting. It's supposedly an incredibly moving experience to witness an eclipse. If any of you managed to see the most recent one, let me know in the comments below. So here comes the moment of truth. How do all these natural cycles stack up to mankind's impact on our climate? These cycles in the position of the Earth, the ebb and flow of its winds, the churning of its core, and the far-reaching influence of its celestial neighbors, all have an influence on the planet we live on. They move in rhythms that are predictable and solid, even if they sometimes take place over time spans that are so large that we don't always live to see them fully play out. Once we understand them, our understanding of our planet deepens. We're able to predict what's coming, whether it's floods, hurricanes, or solar eclipses. But more importantly, we gain the insight needed to act responsibly. We are part of this grand cosmic ballet, and every move we make reverberates through the fabric of the universe. It's up to us to ensure that our actions contribute to the harmony rather than disrupt it. Let's work together to create a future where humanity and nature coexist in balance, each supporting the other in the dance of life. Next, we'll explore how these celestial influences translate into tangible effects on our daily lives, and what steps we can take to mitigate their impacts. Intricate web of natural and human-driven influences on our planet, we arrive at a pivotal moment in our understanding of climate change. Beyond the cyclical rhythms of nature and the celestial influences we've explored, there lies an unprecedented shift that has captured global attention. It's getting hot outside. Nowadays, it's difficult to turn on the news without hearing someone talking about global warming. Headlines are filled with references to rising temperature levels, fossil fuels, and encroaching danger. And the discussion around the subject has gotten as heated as the weather. This has been a topic I've been wary about weighing in on, simply because of how sensitive a subject it has become in recent times. I didn't want to simply create more noise. However, I do now think there is something worth adding to the discussion. After all, there is plenty we hear about the current temperature of the planet. What is often not talked about is the patterns of temperature change that existed in the past that contextualize that modern temperature. Are we really the hottest we've ever been? Scientists believe that in the last 100 years the global temperature has been increasing, but how does this fit into wider patterns and trends? And how did they find any of this out? Well, to answer that question, we need to know, what did the temperature used to be? It's easy to find the current global temperature today. All you need is a thermometer, and you can go outside and take a reading. With enough readings taken at different locations around the globe, you can find an average temperature for the whole planet. Scientists have actually been doing this since 1850, meaning that our records on average global temperatures are fairly accurate since this date. However, mercury thermometers were only invented in 1714. So how do we know what the temperature was before these global readings started being taken? How do we know the temperature 1,000 years ago, or even 1,000,000 years ago, before humans were on the scene? Some of you may already know the answer, or at least a partial answer. Scientists can approximate global temperatures in the past through ice coring. Essentially, when snow falls because it is powdery, it traps little bubbles of air where it lands. If this snow doesn't melt, but has more snow fall on it later, such as in a very cold place like a glacier, you can end up with layers of snow and ice-trapped air bubbles, going back for many, many years. It creates something similar to the rings on a tree. By collecting ice formed this way, scientists can take sections to a lab and melt it, releasing the air relating to specific years. They then can measure the different ratios of gases released from the air bubbles, which tells them the atmospheric composition at that time. And because we can test how much heat is retained by a gas when exposed to a constant temperature like the sun, for instance, CO2 retains more heat while oxygen retains less, with enough samples, scientists can calculate roughly what the global temperature was during that year. However, the oldest glaciers are only 1,000,000 or so years old. To get a good idea of the trends that govern global temperatures, we are going to need to go back much earlier than that. How do we know what the temperature was over 1,000,000 years ago? The answer might surprise you. Clams. Actually, not clams, but something similar. A tiny single-cellular organism, no larger than a full stop, called foraminifera. Like clams, these organisms produce shells around themselves, and these shells are slightly porous. Oxygen in particular is taken into the shell and trapped there, remaining in place even when the foraminifera dies. So, using a similar process to the ice cores, if scientists can find shells of dead foraminifera from a particular year, they can release that air and can work out from it the global temperature. This process is slightly different, as instead of air composition, scientists are looking at different oxygen isotopes, but basically it's a very similar process. Foraminifera are still around today, and first came onto the scene 500 million years ago, so they are instrumental in helping us get a clear picture of global temperatures during this much longer time period. But what is that picture? Based on data collected from foraminifera, it looks something like this. There's a certain degree of uncertainty to this. Findings get more reliable the closer we get to the present day. But as you can see from general trends, the Earth's temperature has undergone significant changes over the last 500 million years. At times, it has faced temperature averages 14 degrees C hotter than we have today, and at other times about -5 degrees C lower. So we are not the hottest we have ever been. Then again, that's not surprising to anyone who knew that the surface of the Earth when it was just formed was molten. So what does this tell us about our current climate crisis? It shows that while the Earth has always undergone temperature fluctuations, the rapid rate of change we are experiencing now is what sets this period apart. The significant rise in temperatures over the past century is largely attributed to human activities, particularly the burning of fossil fuels and deforestation. This accelerated warming poses unprecedented challenges for ecosystems, weather patterns, and human societies. But knowledge is our greatest ally. By understanding the natural and anthropogenic factors influencing our climate, we can develop strategies to mitigate our impact and adapt to the changes already in motion. Through science, innovation, and collective action, we have the power to shape a sustainable future for our planet. As we continue to explore the mysteries of the cosmos and our place within it, let us remember that we are all stewards of this Earth, responsible for its well-being and the legacy we leave for future generations. Stand on the precipice of a new age in climate understanding, we must also consider radical solutions to the pressing challenges we face. One such solution is geoengineering, the deliberate intervention in the Earth's natural systems to counteract climate change. While this may sound like science fiction, it is rapidly becoming a topic of serious scientific inquiry and debate. Geoengineering encompasses a range of techniques and technologies aimed at reducing global temperatures. These can be broadly categorized into two main approaches: solar radiation management, SRM, and carbon dioxide removal, CDR. SRM techniques focus on reflecting a small percentage of the sun's light and heat back into space, thereby cooling the planet. This can be achieved through methods like stratospheric aerosol injection, where tiny reflective particles are released into the upper atmosphere, mimicking the cooling effects of volcanic eruptions. On the other hand, CDR strategies aim to remove carbon dioxide from the atmosphere and store it safely. This could involve techniques like afforestation, where large-scale planting of trees absorbs CO2 or more advanced technologies like direct air capture, which uses chemical processes to capture CO2 directly from the air. While these approaches hold promise, they also come with significant risks and ethical considerations. The potential for unintended consequences is high, as altering one part of the Earth's system could have cascading effects on others. Additionally, the deployment of geoengineering technologies raises questions about governance, equity, and the potential for misuse. Despite these challenges, the urgency of our current climate crisis has led some scientists and policymakers to argue that geoengineering should be part of the broader toolkit for addressing climate change. It is not a silver bullet, but rather a potential complement to reducing greenhouse gas emissions, transitioning to renewable energy, and enhancing natural carbon sinks. As we navigate this uncharted territory, it is crucial to approach geoengineering with caution, rigorous scientific research, and robust international collaboration. The decisions we make today will shape the future of our planet and the legacy we leave for generations to come. It becomes apparent that the science is only one side of the coin. The ethical dimensions of geoengineering present a complex web of questions that humanity must confront. Geoengineering, by its very nature, involves significant intervention in the Earth's systems. This raises profound ethical questions. Who gets to decide if and when these technologies are deployed? What are the long-term impacts on ecosystems and human societies? And who bears the responsibility for any unintended consequences? One of the primary ethical concerns is the issue of governance. Geoengineering is a global intervention, and its effects will be felt worldwide. This necessitates a framework for international cooperation and decision-making. Without such a framework, there is the risk of unilateral action by individual countries or entities, which could lead to geopolitical tensions and conflicts. Moreover, there is the question of equity. The impacts of climate change are not evenly distributed across the globe, nor will the benefits and risks of geoengineering be. Developing nations, which are often the most vulnerable to climate impacts, may not have a say in decisions that could drastically affect their environments and communities. Ensuring that all voices are heard and considered in the geoengineering debate is crucial for maintaining global equity and justice. The potential for misuse of geoengineering technologies also cannot be ignored. In the wrong hands, these powerful tools could be weaponized, leading to environmental manipulation for political or economic gain. This underscores the need for stringent regulations and oversight to prevent such scenarios. Furthermore, geoengineering presents a moral hazard. Relying on technological fixes could detract from efforts to reduce greenhouse gas emissions and transition to sustainable energy sources. It is essential to view geoengineering as a complement to, rather than a substitute for, these crucial mitigation strategies. As we navigate the ethical landscape of geoengineering, it is vital to approach it with humility and caution. Robust scientific research, transparent decision-making processes, and inclusive global dialogue are imperative. The stakes are high, and the decisions we make today will reverberate for generations to come. The role of global cooperation in addressing our climate challenges and the potential pathways to a sustainable and resilient future. Together, we can forge a path that respects both the science and the ethics of our interventions in the Earth's systems. Concept of geoengineering, it becomes apparent that the science is only one side of the coin. The ethical dimensions of geoengineering present a complex web of questions that humanity must confront. Geoengineering, by its very nature, involves significant intervention in the Earth's systems. This raises profound ethical questions. Who gets to decide if and when these technologies are deployed? What are the long-term impacts on ecosystems and human societies? And who bears the responsibility for any unintended consequences? One of the primary ethical concerns is the issue of governance. Geoengineering is a global intervention, and its effects will be felt worldwide. This necessitates a framework for international cooperation and decision-making. Without such a framework, there is the risk of unilateral action by individual countries or entities, which could lead to geopolitical tensions and conflicts. Moreover, there is the question of equity. The impacts of climate change are not evenly distributed across the globe, nor will the benefits and risks of geoengineering be. Developing nations, which are often the most vulnerable to climate impacts, may not have a say in decisions that could drastically affect their environments and communities. Ensuring that all voices are heard and considered in the geoengineering debate is crucial for maintaining global equity and justice. The potential for misuse of geoengineering technologies also cannot be ignored. In the wrong hands, these powerful tools could be weaponized, leading to environmental manipulation for political or economic gain. This underscores the need for stringent regulations and oversight to prevent such scenarios. Furthermore, geoengineering presents a moral hazard. Relying on technological fixes could detract from efforts to reduce greenhouse gas emissions and transition to sustainable energy sources. It is essential to view geoengineering as a complement to, rather than a substitute for, these crucial mitigation strategies. As we navigate the ethical landscape of geoengineering, it is vital to approach it with humility and caution. Robust scientific research, transparent decision-making processes, and inclusive global dialogue are imperative. The stakes are high, and the decisions we make today will reverberate for generations to come. Join us in the next chapter as we explore the role of global cooperation in addressing our climate challenges and the potential pathways to a sustainable and resilient future. Together, we can forge a path that respects both the science and the ethics of our interventions in the Earth's systems. They rise and fall, compounding with each other at times, and at others working in opposition. While their extremes can be destructive, by learning about them, we can learn to live with them. And they certainly make sure that life on Earth is not boring. We as humans are now a part of that process, although whether we will prove to be cyclical too remains to be seen. Perhaps our mastery of this planet will increase until these cycles are no match for us, and we will be able to set the weather and the temperature to whatever we want it to be in a given moment. But those days are a long way away. For now, it's so important to understand the cycles of the planet and how we are influencing them. Because whether we are ignorant of them or not, they will influence us. At least now, when someone offers you polite conversation about how is the weather, you know enough to take it a little farther. Turn to them and say, "Too easy, I can tell you why is the weather." They may or may not appreciate that answer, and it might be the end of the conversation. But in my opinion, it's a fascinating subject to know about.